Welcome, ladies and gentlemen. My name is Mekalavash Reddy, and I am going to present a presentation on Cauchy's asymptotic properties on median point. So, I'm currently pursuing my BTech in Institute of Aeronautical Engineering in Artificial Intelligence and Machine Learning. So, coming to our topic, so these are some of the topics I am going to discuss in my presentation. So, types of mean value theorem, Cauchy's mean value theorem, which is going to be heart of our topic, and also this also explains us about the asymptotic properties of Cauchy. So, problems for our better understanding and also gives us a clarity on this topic. So, asymptotic properties for median points, which is going to be a core of the topic, and some of the theorems which explains us about such asymptotic properties of Cauchy's for median points, and the required equation which is which also explains us as asymptotic properties but gives us an approximation on our topic. So let's get started on our presentation. Mainly, our topic is originated from Taylor's theorem, which is in calculus. Taylor's theorem gives an approximation of a k times differentiable function around a given point by polynomial of degree k called the kth order Taylor polynomial. For a smooth function, the Taylor polynomial is the truncation at order k of Taylor series of function. The first order Taylor polynomial is the linear approximation of the function, and the second order Taylor polynomial is often referred to as quadratic approximation. There are several versions of Taylor's theorem, some giving explicit estimates of approximation error of function by its Taylor polynomial. So let's get moving on to our next slide. Types of mean value theorems. The below mentioned are originated from Taylor theorem and are known to be the pillar of calculus employed graph. Rowley's mean value theorem, Lagrange's mean value theorem, and Cauchy's mean value theorem, which is going to be heart of our presentation. So Cauchy's mean value theorem was discovered or was given clarity by Cauchy at early 18s, which gives us a clarity or the relationship between the graphical representations and the calculus, which being two parallel, two parallel and also two intersected between them. So let's get started with our topic. According to Cauchy's mean value theorem, let two functions be f of x and g of x. These functions must be continuous on a comma b or interval a comma b. These functions must be differentiable on interval a comma b, but g differentiation of x must not be equal to 0 in interval a comma b. This theorem also sums up Lagrange's mean value theorem. So let us find out how Cauchy's mean value theorem sums up Lagrange's mean value theorem. On substituting the functions, we get f differentiation of c divides g differentiation of c, which is equal to f of b minus f of a divided by g of b minus g of a. But if we substitute x equal to g of x, then we are going to get f differentiation of c is equal to f of b minus f of a divided by b minus a, which is our required Lagrange's mean value theorem. So let's get moving on our next slide. Oh, by the way, The graphical representation of Cauchy's mean value theorem is above here. This is the graphical representation of Cauchy's mean value theorem, and this is sinusoidal in shape, as you can observe. So some of the problems on Cauchy's mean value theorem which are going to give us a better understanding on Cauchy's mean value theorem. Let us now check the validity of Cauchy's mean value theorem for two given functions. The given functions are f of x equal to x power 4 comma g of x equal to x square. We have to find the validity of them in the interval 1 comma 2. We know according to Cauchy's mean value theorem, function must be continuous at interval and should be differentiable. But every polynomial is differentiable and continuous at the interval. So by Cauchy mean value theorem, f of x equal to 4 x raised to power 3 and g of x equal to 3 x raised to power 2. So by Cauchy's mean value theorem, f of x differentiable by g of x differentiable is equal to f of b minus f of a divides g of b minus g of a, or we can say f dash of c divided by g dash of c is equal to f of b minus f of a divided by g of b minus g of a. So let us substitute the values in the given equation. 4x cubed divided by 3x square is equal to b power 4 minus a power 4 divided by b square minus a square. So by solving this equation, we are getting 4x cubed by 3x square is equal to b square minus a square into b square plus a square divided by b square minus a square. Here, two expressions shall be cancelled out to get our answer as c is equal to square root of b square plus a square divided by 2. So by substituting a is equal to 1 and b is equal to 2, we are going to get c is equal to plus or minus root over 5 divided by 2, which is our final answer, and hence Cauchy's mean value theorem has been verified. So with this, we are with this, I am assuming that we are going to get a clarity on Cauchy's mean value theorem. So let's get moving on to the next slide. So asymptotic properties for median point of Cauchy's mean value theorem is discussed in a weak condition and a universal result is obtained as a deduction. The result be used to an asymptotic property for median point of Leglage's mean value theorem. So this is a required theorem for asymptotic properties of Cauchy's mean value theorem. So this theorem explains us detailedly and briefly about asymptotic properties for median points of Cauchy's mean value theorem. So if we say f of x and g of x have first order derivatives in interval e a comma d and g of x is not equal to 0 for x raised power 1 e at the interval a comma d. Suppose limit of to a x to a g differentiation of a f differentiation of x minus f differentiation of a into g differentiation of x divided by x minus a whole power p plus q. And also another equation is limit x to a g differentiation of x divided by x minus a is equal to a not equal to 0. So where p nu p nu 0, comma p nu minus 1, then for median point n between a and b in Cauchy mean value theorem, we have the required equation, which is limit of e minus a limit of e minus a at x to a is equal to q minus 1 divided by p minus q minus 1. Let us apply L'Hospital rule for this equation. So we are going to get the final equation as limit of e minus a divided by x minus a is equal to 1 by p plus 1 raised to power p. So this is our final theorem, which states asymptotic value of Cauchy's mean value theorem. So this is our required equation of Cauchy's mean value theorem for median points, which is going to give us a clear clarity on the topic. So thank you guys for your cooperation and an exceptional and an exception. So thank you all for giving me your time. So thank you all.